exponential equations. We've seen very simple ones. I guess these are the first sort of exponential equations we saw. 5 to the power of x equals 125. What's x? Oh, x cubed, that's 125. Then we got a little bit fancier. 4 to the power of 2x plus 1 is 1 on 2 root 2. So we had to rewrite everything for this one so that the base was 2. And we ended up with 4x plus 2 is minus 3 on 2, 7 on 8 for x. And then we went, hang on a sec, 7 to the power of something 32? Can't do that. What's going on there? So that's when logs came in handy. To undo the exponential, log both sides. But the base has to be the same. I don't have base 7 on my calculator. I've only got base 10 or the natural base e. So that's why we have a change of base formula, which allows us to put it into one of those two bases. So log of x to some unusual base will be log of x to the base we know, divided by the log of that unusual base. I've changed mine to, which ones do you think I used? Actually, it doesn't matter, I get the same answer regardless. So whatever base you do, it will come out to be 1.781. If you don't believe me, try both buttons on your calculator. Not a different one for each one, but try the natural log and you'll get the same one. Okay, so 3 to the power of x equals 5 to the power of x minus 2. I can't do this one simply by just logging both sides, can I? Yes, I can. So long as the base of the log's the same, we'll be okay. Because then I can use that log law that allows me to bring the powers out the front, and I'm just trying to make x the subject. So 2 log 5 over log 5 minus log 3. Once again, it doesn't matter which log button you use, you should get the right answer of 6.301. Here's an exponential equation, but it's a quadratic because, of course, you could rewrite 9 to the power of x as 3 to the power of x squared. Now, I probably wouldn't write all that down, but we're basically just turning it into a quadratic. M squared minus 4m plus 3 equals 0. Multiply this together to give 3, adds to give negative 4, minus 3 and minus 1. So m equals 3 or m equals 1, but that's not my final solution, of course. It's x we're trying to find. So 3 to the power of x is 3. Well, that's a nice easy one. And 3 to the power of x is 1. Well, that's not too bad either. So we've got x equals 1 or x equals 0. In equations, when we're talking about continually increasing or continually decreasing functions. So when a function is applied to an inequation, that inequality sign will be preserved or maintained if the function is continually increasing. The sign will change if the function is continually decreasing. So if we got something like this, so I guess it has got something to do with exponential equations, but this is an inequation. So 1 is less than 2 to the power of x is less than 32. Now, exponential and log functions, both of them are continually increasing. So regardless of what I use, an exponential or a log function to solve this problem, that inequality is going to be preserved. So I could just find the log of all three things, and it will still be in the same order. So log 1 base 2, well that's 0. Log 2 base 2 is obviously 1, so we just get x. And log 32 base 2 is 5, so x is in between 0 and 5. So log x base 3 is greater than 2. In this case I'm exponentializing both sides. So x is greater than 9. X is greater than 9. Okay, that'll do us. Exercise 8e.